Next, we're going to consider a balance gene. And it says we didn't know about this gene ahead of time. And that's the thing about these kinds of experiments, is you can't necessarily imagine or think of every possible confounding variable. There could be ones that you never even considered. So again, you're going to do what it says here. You still have the applet open. Select Reveal Gene button and then select Gene from the pull-down menu. And I have a screenshot of this. Okay, so I've selected Reveal Gene here, and then I selected Gene from the pull-down menu. So the question is, does the person have the gene or not? So notice we're keeping track of whether the person has the gene, and that is categorical, and it's also binary, and you see here it's either yes or no, they have the gene or they don't. And so because my variable is categorical, the computer is calculating the proportion of people with the gene in each group. And then again, the graph at the bottom is finding the difference in those sample proportions. So in this last of the 200 shuffles and deals, half the people in group 1 had the gene, half the people in group 2 had the gene. So when I would subtract 0.5 minus 0.5, I would get 0 as my difference. So once again, this graph is bell-shaped. It's centered at 0. So there is a tendency for the groups to be balanced on whether people have the gene or not. We're not getting one group where everybody has the gene and the other group nobody does, right? In each group, there tends to be a similar proportion of people that have the gene. Okay, so when we go back to number 11, it says, does this variable tend to equalize between the two groups in the long run? And the answer is yes. Explain. So the graph of difference in proportion of people that have the gene between the two groups is bell-shaped and centered at 0 once again. So what does that mean? It means that we tend to get a similar mixture of people in each group that have the gene. So the centering at 0 is important because that shows that the most common outcome is for the two groups to have the same proportion of people with the gene. So when you subtract the proportions, you get 0. And the bell-shaped is important because it shows the tendency is for differences to be around 0, close to 0, and the further away from 0 you look, the shorter the bars, the less likely you are to have a difference that big between the groups. So the tendency, just like in number 10, is for the groups to be balanced on whether or not people have the gene. All right, now let's look at number 12. Suppose there were other X variables that we could not measure, such as stride rate or walking speed. Select the Reveal Both button and use the pull-down menu to display the results for this X variable. Does random assignment generally succeed in equalizing this variable between the two groups, or is there a tendency for one group to always have higher results for the X variable? So again, you want to select this Reveal Both box and then select X variable. So notice that each card now has the person's name and their height and whether or not they have the gene and the value for this X variable, whatever it is. So this X variable now is quantitative, right? You can see the values of it in each group and on each card. This is quantitative. So the way that I summarize that is by taking a mean. So I'm finding the mean X variable value in each group and then again finding the difference in means each time. So on this graph are 200 dots from 200 differences calculated from a replication of shuffle and deal, calculate the average of the x variable values in each group and then find their difference. Now again, this mean is close to 0. You notice this is bigger than the other means. It's not as close to 0, but also the variability, the standard deviation, is higher. So relative to the standard deviation, this mean is about 0. And you can just look at the picture and see that it's centered around 0. It's not as bell-shaped as the previous ones, but it's roughly bell-shaped. It's fairly symmetric. So as the question asks in number 12, is there a tendency for one group to always have higher results for the x variable? If that were the case, then our graph might be centered, for example, at a difference of 5 and be bell-shaped around that. In that case, then group 1 always tended to have a higher value for the x variable, so the mean was tended to be 5 points higher in group 1 than in group 2 for whatever this x variable is. That's not what happened here. Okay, so does random assignment generally succeed in equalizing the variable between the two groups? Yes. Graph of difference in the x variable means is bell-shaped and centered at 0. So once again, the tendency is for the groups to be balanced we might say with respect to this x variable, which we don't even really know what it is, but it might be important to a person's ability to recover. So let's read the key idea. Randomly assigning experimental units to groups, like by putting everybody's name in a hat and mixing them up and randomly picking out 12 for each group, or putting everybody's name on a card and shuffling up the cards and dealing them out to two groups. Randomly assigning experimental units to groups tends to balance out all other variables between the groups. Any variable that could have an effect on the response should be equalized between the two groups and therefore should not be confounding.